Hey guys, so we're going to be taking a look at one of the exam 1 problems. As you guys know, your extended chem exams are all cumulative, so some of the stuff that you will see in exam 1, you'll see in exam 2, right, and so on. And I want to make sure that you guys feel comfortable with all of the material, right? So if you're not sure on something from one of the previous exams, you got to make sure that you know it because it could show up at any time on your next exams, right? So this problem was highly controversial for a little bit, and I can understand why, but I want to show you guys how I did it. So the equation that I ended up using, a little bit different than something that you guys would have that seemed to work for me. While I'm not completely sure if it's going to be the correct answer, I'm almost fairly certain that it is, but I have no way to confirm that it is. I used something like this, where V0 is threshold frequency, and V is just frequency. And H is obviously Planck's constant. And Ke is kinetic energy. So we have a couple of these things. We have almost pretty much everything given to us in the actual problem, right? So how I would fill this out, right? Something like this. I'm going to use a bigger marker so you guys can see, but 3.29 times 10. Actually, I'm going to run out of space. So how about we do it a little below? 3.29 times 10 to the negative 21st equals Planck's constant is 6.626, 10 to the negative 34, V minus 6.26 times 10 to the negative 34, V0. We're going to be solving for V0 in this case, right? That's going to give you your binding energy. And so how are we going to find V? Well, they've actually given you your wavelength, right? So with that, to find V, an easy way would be your speed of light over lambda. So you know that that's going to be 2.998 times 10 to the 8th over. Since it's nanometers, you got to make sure you convert it to meters, so it should be something like 10 to the negative 7. So your frequency is going to equal 4.314 times 10 to the 14th. So now if you plug that in, right, your V is going to equal that. I'll give you guys the full equation, and then you guys can sort of solve from there. And then you solve for V0, and I ended up getting the second option, which is 4.26 times 10 to the 14th joules. So if you end up solving for this, right, you'll end up getting something like this. I believe that makes sense, but if it doesn't, let me know. We can always email about it. I think this problem is a little tricky, but remember, I think that sodium lamp is something that you guys should focus on, problems like that. Some of the stuff that we did in the review section, take a look at those problems. Binding and threshold frequency, of course, are really important problems to focus on, but sometimes they can get confusing, and it's just going to perpetuate the problem if the actual exam problem was incorrect. Sometimes it's just going to become cyclical and nobody's going to understand it. So, focus our efforts on some of the other things that are actually going to get tested on, and then try variations of these problems that are correct. moving away from the quiz. Go look at reviews, go look at online resources, try to do other stuff with threshold frequency and binding energy, and maybe you'll start to get an understanding moving away from this singular problem, right? So let me know if you guys need help with anything else, but signing off for now. All right, thanks.